Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very complex number. We have ln z and square root of z, and they are equal. Before we start solving this problem, think about how you could solve it. First of all, can you guess and check? For example, would z equals 1 work? Could we find a real solution? So on and so forth. Obviously, the real numbers would be the easiest to check in this case, right? And now let's go ahead and take a look at a graph of these two functions, right, in the real world. Well, looks like ln z is going to intersect the x-axis, or whatever the axis is, at 1. So it'll have an intercept. And then as z approaches 0 from the right, the ln z values are going to approach negative infinity. And the other graph is the square root graph, and notice that the square root is going to grow faster, right? Don't you think? Than the ln, and they will never intersect, which means there are no integers. There are no real solutions. But wait a minute, isn't this channel all about complex numbers? Well, real numbers are a subset of complex numbers, so some solutions can be real, right? Anyways, this is a non-standard equation, and we're going to solve it using a special method. So our equation is ln z equals square root of z. I know square root of z is kind of ambiguous because a complex number has two square roots, but let's just consider both cases, right? Whatever z is, we're also going to consider its both square roots, in other words. Anyways, we're also going to be looking at something that we get from Wolfram alpha, which was a little surprising. Anyways, can we use Lambert's W function to solve this problem? You know, when we have something like ln z equals z, or even z ln z equals something, we could probably use it, right? Or even better, z times e to the z equals something. Obviously, this would be the direct application. The others would take a little bit more work. But this one has a square root, so what are we supposed to do, right? Yeah, I don't want you to insert the last image. Notability. So calm down. So what do? We're going to go ahead and try to make it appropriate for Lambert's W function. And Lambert's W function is basically a function that accepts an input like t e to the t. T is my favorite drink, by the way, and outputs t. You see, it's basically the inverse of the function that's defined by f of t equals t e to the t, and it's also called product log. If you're going to enter it into Wolfram alpha, I believe you have to write product log, or maybe there's another way to write it with w underscore something, but I'm not completely sure about that. Anyways, let's go ahead and see if we can make it into this form, t e to the t. So let's go ahead and move z to the power 1/2. Wait a minute, what did I say? Square root of z, let's write it as z to the power 1/2. I want to move z to the power 1/2. I don't want to move ln z, because moving ln z is not going to be a good idea. You're going to end up with something like 1 over ln z, which is, I don't think is going to go into this form. So let's do this. ln z equals z to the power 1/2. And then what I want to do here is multiply both sides by z to the power negative 1/2, so that I can get a 1 on the right hand side. In other words, I'm dividing both sides by the square root of z. You could also write it this way: ln z equals square root of z, and then divide by square root of z, and then just do the algebra. Same thing, right? Makes sense? Okay. I hope it does, and let us know if it doesn't. But this becomes 1, z to the power 0, and this becomes what it is, z to the power negative 1/2 times ln z equals 1. Now, whenever you have something like z times ln z, it can be turned into t e to the t with a little bit of substitution. But this one is a little different because we don't have z inside the ln. So the argument for the ln is not z to the power negative 1/2. Wait a minute, we can make that. What is ln z to the power negative 1/2? Just imagine what would happen if z had that power. It would just mean that this could be moved and written as negative 1/2 times ln z. So that's what I exactly need. You see that? I do need to multiply both sides by -1/2, and that'll do the trick. So it's all about tricks or about math and magic. So z to the power -1/2 times -1/2 times ln z equals -1/2, because 1 times -1/2 is -1/2. And now we're going to go ahead and put this back here, and we'll get z to the power -1/2 times ln z to the power -1/2 equals -1/2. A lot of -1/2s, right? Now, before we put it in the t, well, how do you put it into te to the phi form from here? You would need to get rid of the ln. So that kind of calls for substitution. You can go ahead and call this ln z thing. No, I don't want you to insert. Okay, when I press and hold, I think that's what it does. But anyways, I want to do the following. Can I write the z to the power -1/2 as e to the power ln z to the power -1/2? That's kind of like a convoluted way to write it, but think about it. Whenever you have something like y, it can be written as e to the power ln y. That's what I exactly did here. Think about this as y. That's what I did. Make sense? And this is equal to -1/2. Awesome. Now, this is my t, and this is my e to the t. You got it? So, when you apply Lambert's w function on this, w of ln z to the power -1/2 times e to the power ln z to the power -1/2, and of course you have to apply it on both sides, is going to give you this only, because that's my t, right? And wt to the t is just t. So t will be, or can I just write the t as ln z to the power -1/2 equals w of -1/2. Awesome. This is not very helpful, but at least we can do the following. Bring this -1/2 to the front. That's going to be -1/2 times ln z is numbers w of -1/2. And then we can multiply both sides by -2, and ln z is going to be -2 times w of -1/2. We're going to look at the numerical value, don't worry about it. But if you want to find z from here, of course, we would just use the identity. Z equals e to the ln z. So do e to the power on both sides. You're going to get z equals, so I should probably do it the other way around. E to the power ln z equals z, which is e to the power -2 times w of -1/2. So this would be the solution, or would this be the solutions? Let's go ahead and take a look at a couple things, such as some results from Wolfram Alpha. Wolfram Alpha gave me two complex solutions. Which one is correct? Are they both correct? That's a good question, right? So we kind of have to think about, do you think when I square root these numbers and ln these numbers, they can be equal, right? You have to think of each case. But when I evaluated the expression that I got at the end of my solution, I only got a single answer, which gives me the minus sign. So the second solution may not work. Why did Wolfram Alpha throw it at us? Maybe it's the conjugate. You're going to answer that question. That's your homework. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.